From discarded water bottles to aged window frames, plastic has proven to be an exceptionally versatile material. Yet this durability has become its downfall as it persists in the environment for centuries, with over 300 million tons of plastic produced annually, much of which eventually ends up in landfills or polluting our oceans. It's no wonder that recycling plastic has become a pressing global issue. Recycling plastic traditionally involves melting down and reprocessing plastic waste into new products. However, this approach presents its own set of challenges. It's not only an expensive endeavor, but also often results in a significant degradation in the quality of the recycled material. Now, what if there was a revolutionary solution that could address these challenges head-on? Enter additive manufacturing or 3D printing. This technology holds immense promise for transforming the plastic recycling industry by offering a unique approach that could reduce waste, lower costs, and minimize environmental impact. In this video, we'll explore the exciting potential of how 3D printing can redefine plastic recycling. Join us as we delve into the innovative ways 3D printing is addressing plastic pollution, enhancing efficiency, and paving the way for a more sustainable future. But before we dive into the details, let's take a moment to appreciate the incredible journey that plastic has taken from its humble beginnings to its ubiquitous presence in modern society. Since its inception in the mid-20th century, plastic has revolutionized numerous industries with its versatility, durability, and affordability. From packaging and construction to automotive and aerospace applications, plastic's impact has been nothing short of transformative. However, this very durability has become a double-edged sword as plastic waste has wreaked havoc on the environment, clogging landfills and polluting our oceans. As we grapple with the consequences of our plastic addiction, the urgent need for efficient and sustainable recycling solutions has come to the forefront. Fortunately, 3D printing is emerging as a beacon of hope in this battle against plastic pollution. By offering a cost-effective and eco-friendly approach to recycling, this innovative technology empowers us to turn trash into treasure and pave the way for a cleaner, greener future. Now that we've established the importance of recycling plastic, let's turn our attention to the process itself. Conventional recycling methods have their limitations. They are often expensive and time-consuming and can result in a noticeable decline in the quality of the recycled plastic. So how can 3D printing disrupt this status quo? Well, it all begins with understanding the fundamentals of 3D printing. This revolutionary process involves building three-dimensional objects layer by layer from a digital design. But what sets it apart from traditional manufacturing techniques is the level of precision and customization it offers. With 3D printing, manufacturers can create intricate designs that would be impossible or prohibitively expensive to produce using conventional methods. This level of precision allows for the creation of lightweight, durable parts with minimal material waste, making it an attractive alternative to traditional recycling processes. One of the most significant advantages of 3D printing in plastic recycling is its ability to work with a wide range of plastic materials. Unlike traditional recycling, which often focuses on specific types of plastic, 3D printing can accommodate a broader spectrum of materials, including those that are difficult to recycle using conventional methods. This flexibility allows recyclers to handle mixed plastic waste streams, reducing sorting costs and increasing the overall efficiency of the recycling process. Furthermore, 3D printing offers unparalleled design freedom, enabling manufacturers to create innovative and functional products from recycled plastic. This opens up a world of possibilities, allowing for the creation of everything from household items to automotive components. Another compelling aspect of using 3D printing in plastic recycling is the localized nature of the technology. Unlike traditional recycling facilities, which are typically centralized operations, 3D printing can be implemented at a much smaller scale, even at the local level. This decentralized approach not only reduces transportation costs but also empowers local communities to take control of their plastic waste. By enabling individuals, schools, and small businesses to recycle plastic into useful products, 3D printing fosters a sense of responsibility and ownership over the recycling process. But how does 3D printing specifically address the challenges associated with plastic recycling? Let's start with the sorting problem. Traditional recycling processes require the separation of different plastic types, which can be both labor-intensive and expensive. 3D printing circumvents this issue by accepting a wider range of plastic materials, reducing the need for extensive sorting. The technology's adaptability allows for the processing of mixed plastic waste streams, leading to significant cost savings. Additionally, 3D printing offers a flexible solution to varying material properties. Plastic materials can undergo degradation during the recycling process, resulting in inconsistencies in quality and performance. However, 3D printing's precise material extrusion capabilities allow for the creation of parts with consistent quality regardless of the variability in the recycled plastic. This level of precision ensures that the final product meets the required specifications and performs as expected. So how do we go about incorporating 3D printing into the plastic recycling process? One effective approach involves shredding the plastic waste into small pellets, which can then be converted into 3D printer filament. This filament can be used to create new plastic objects through 3D printing, effectively giving discarded plastic a new lease on life. It is like taking something old and worn out and transforming it into something beautiful and useful once again. And the best part is that this process is not only environmentally friendly, but it's also cost-effective and efficient. By reducing the need for virgin plastic, we not only conserve natural resources, but also reduce the demand for fossil fuels, leading to a more sustainable future. So why settle for traditional recycling when you can have something better? Embrace the future of plastic recycling with 3D printing. Give your waste a chance to shine again. And now let's explore some real-world examples of how innovators around the world are already harnessing the power of 3D printing to revolutionize plastic recycling. Take, for example, a company that is transforming ocean plastic into valuable products using 3D printing technology. Their innovative approach not only helps clean up our oceans, but also creates unique and durable products that raise awareness about the impact of plastic pollution. Another inspiring initiative is a school program that has integrated plastic recycling and 3D printing into their curriculum. Students learn valuable skills while creating useful items from recycled plastic, fostering a sense of environmental responsibility from an early age. These are just two examples of how 3D printing is transforming plastic recycling and making a positive impact on the environment and local communities. But what does the future hold for 3D printing and plastic recycling? As technology continues to advance, we can expect even more innovative applications and benefits. Imagine a world where autonomous 3D printers work alongside advanced sorting systems to efficiently recycle plastic waste at a large scale. The combination of automation and artificial intelligence could optimize the recycling process, reduce costs, and improve efficiency. Moreover, 3D printing can play a crucial role in creating a circular economy for plastic. By enabling the production of high-quality recycled plastic, 3D printing reduces the reliance on virgin plastic, conserving valuable resources and minimizing waste. As more businesses and consumers embrace sustainable practices, the demand for recycled plastic is likely to grow, creating new opportunities and driving innovation in the field. The potential of 3D printing and plastic recycling is vast, offering a promising solution to one of the most pressing environmental challenges of our time. By harnessing the precision, flexibility, and accessibility of 3D printing, we can transform plastic waste into valuable products, reduce reliance on fossil fuels, and create a more sustainable future. So let's continue to support and invest in research and development, promote collaboration among innovators, and raise awareness about the benefits of 3D printing and plastic recycling. Together, we can pave the way for a cleaner, greener planet and ensure that plastic waste becomes a thing of the past. We encourage you to stay informed about the latest developments in 3D printing technology and its applications in plastic recycling. Attend industry events, connect with experts, and explore the possibilities firsthand. Your active participation can help drive the adoption of sustainable recycling practices and make a lasting impact on the environment. In conclusion, as we look to the future of plastic recycling, 3D printing emerges as a beacon of hope and innovation. Its ability to transform plastic waste into valuable products, coupled with its efficiency, flexibility, and accessibility, makes it a game-changing solution to the plastic pollution crisis. By embracing 3D printing, supporting research and development, and promoting responsible consumption, we can pave the way for a more sustainable future. So let's join hands and turn plastic waste into a thing of the past, one print at a time.